Hello and welcome to session 254 in the AISafety.com reading group. Tonight we will be discussing the less wrong post, Let's See You Write That Corrigibility Tag by Eliezer Yudkowsky. Eliezer Yudkowsky is the founder of MIRI and the senior researcher and of course the author of this post, but we will also be looking at 19 other posts or comments to this post, most of which are by people that I don't recognize. The post was a couple of months ago, and it's kind of like a competition on Less Wrong, and there is one entry in particular, the one made by Eliezer Yudkowsky, that I will focus on. Note that I did not participate in this competition, and that is of course kind of unfair for me to I have also presented some of the principles that I would add in this competition, but that's after reading everyone else's comments and principles, so that's obviously somewhat unfair. This all started out with Eliezer Yudkowsky in the post AGI Ruin, a list of lethalities, lamenting that it is only him who is writing up the list of lethalities, and no one else seemed to be able to do that. Even Hubinger objected to this, saying that why should other people do that? They are writing the same things, just organizing it in different ways, and in particular pointing to a set of 4 people, even Paul Cristiano, Richard Ngo, and Scott Garrabrant, as 4 people who have written up something that is essentially covers the same part. And so Eliezer Yudkowsky notes in this post that many people could have written a list, that Evan says that many people could have written a list like that, even though obviously you can argue these maybe, if Eliezer Yudkowsky is the best alignment researcher, then this may be number 2 to 5. Of course that's with a big question mark. Here we'll see whether in a competition of who can write lists like this, number 1 is in fact better than number 2 to 5. And the people, Evan Hubinger, Paul Christian, Richard, and Scott, are not really central to this list. So, Eliezer Yudkowsky in the post claims to have been asked, why not challenge others to write such a list in advance? And he is rather negative about this idea. It doesn't do any good, and it doesn't persuade anyone. People don't like tests, and he doesn't believe in such tests, and he couldn't pass a number of similar tests. But oh well, let's try, because if it might be a worthwhile try, sometimes you are positively surprised. So the task is corrigibility. We want to here is Rob Bensinger's definition of corrigibility, the hypothetical motivational system that means that the AI doesn't want to kill you even if you didn't build it correctly. The way Eliezer Yudkowsky writes this is in a tag in Mad Investor Chaos and the Woman of Asmodeus, which is a fanfic, and a tag in this case is some kind of post or reply, in the sense that you are supposed to reply next, because this is co-written together with I think Kelsey Piper. So the topic is the principles of corrigibility, and corrigibility is of course an important subject, and already the framing of principles is somewhat suspect in my mind, in that corrigibility is unlikely to be something that we can in a principled way guarantee, but more like something we obtain through a number of different means. And I think desiderata is a better word, as in we have a large number of things we would like an AI to have, such that it becomes more or less corrigible. Principles are things you don't compromise on at all, and some kind of compromise is almost certainly going to be required. So to ensure that everybody is on the same page, Eliezer Yudkowsky gives 4 examples of principles for corrigibility. Those are myopia, low impact, boundedness, and quantization. So based on this, the people who want to see whether they can take on this challenge and write corrigibility tag, you would expect them to, among the principles of corrigibility, have these 4 things. Write something like principle of myopia. The AI shouldn't only consider short time horizons. Something like that would be very expected, and in fact, none of the 19 people who eventually take up this challenge have all these 4 criteria, desiderata principles: myopia, low impact, boundedness, and quantization. So before we can probably understand the framing, we need to talk about DATHILAN. DATHILAN is a fictional world that is the background to many of Eliezer Yudkowsky's stories, including Mad Investor Chaos. It is a civilization that is capable of solving the alignment problem. It is also a civilization that's good in many other ways. I think you could argue that this is Eliezer Yudkowsky's vision of utopia. There are a lot of people who criticize different aspects of this in different ways. So, but to a first approximation, I think it holds. Lots of people in his stories that criticize part of it, like literally, Mad Investor Chaos is written from the point of view of someone who is kind of not quite an outcast, but someone who certainly doesn't feel at home in DATHILAN. So it's not really a utopia in that sense, or it might be. Okay, how does DATHILAN solve the alignment problem? One of the ways they do that is using a selective breeding program to increase the average and maximum IQ while maintaining other good traits. They have a very great education system with a lot more focus on coordination and economics than we have. Their goal is to eventually build an aligned superintelligence, but they are taking their sweet time in doing this and expect to not really start for a generation or so. Because they are coordinating well enough to ensure that there will in fact not be any kind of race at all. If you there was a link previously posted to the post where Eliezer talks about the principles of corrigibility in this setting. If you want to understand a bit more, I recommend going back approximately 4 posts. You can go back further if you are really keen on reading, I think, almost 2 million words, but that's not really necessary. The context is mostly the past 4 posts. So, even though they want to build an aligned superintelligence, they have another plan, and that is, if something bad should happen really urgently, they are thinking of building a corrigible thing if it becomes necessary to take drastic action. Then they can have and they want to build an AI that can do something very, very important and difficult without killing them all. And in particular, the pivotal act for them is things like stopping a comet rather than our problem of stopping unaligned AGI. And that gives them some very different options that we don't have, because a lot of our pivotal acts are centered around coordination. So this large project has developed 15 principles of corrigibility. And those are, of course, the center of this competition. This is Eliezer Yudkowsky's entry in this competition. These are the 2 main characters in Mad Investor Chaos. And there is 2,169 words in this post. Compared to the other 19 people who replied, this is substantially more than double the second largest, so it is kind of verbose. There is also some text around the principles. I'll get to that later. And one thing we should notice is that it is quite possible for these people to have read each other's entries. And the post times are not really clear. I couldn't find that on Mad Investor Chaos. So, like, a lot of people could have cheated. And I have no way of knowing that, and I'm just going to assume that no one cheated and looked at what other people had written. So this is framed as some kind of competition, and it's a competition without any kind of judge. Perhaps Eliezer Yudkowsky will judge it for himself, but no one will judge this publicly. So I hereby announce myself as the judge of this competition. And the way I will do this is, just to get some kind of sense of it, I will count how many principles have each person suggested. That's a really crude metric, and I know that. In addition, I will look at how many upvotes on Less Wrong did people get. Of course, Eliezer Yudkowsky didn't post on Less Wrong, he posted it on Glowfig. And then I go through all the principles, the 15 principles that Eliezer Yudkowsky listed, and then everybody gets like 1 principle point if they mention anything related to these 15 principles. And I did this in a very, very optimistic sense, in that even if people really wrote very little about a principle, I gave them full point and counted that as a principle. I think definitely if you wanted a more precise measure, you should, like, on a scale from 0 to 1, like how much do they actually write about this principle, and maybe also something about weight, like some principles are probably more important than others. And then other people suggested some principles that Eliezer Yudkowsky didn't mention, I also interpreted that really generously. Like if people wrote a paragraph about just about anything related to corrigibility, then I was willing to call that a principle, even though most people didn't call that principles. So I counted up painstakingly everything, and then I threw the tallied result away and went with my gut feeling. That's a classic rationalist principle way of doing it. So let's see what here you can in fact see my spreadsheet where I calculated everything and wrote down some of the principles that people have. I will go through the results here in a more abbreviated form. So I'll write them down ordered by how many upvotes they got on Less Wrong. Eliezer Yudkowsky didn't, so I just put him arbitrarily on the top here. And then there was Jan Kulveit with 9 principles. Eliezer Yudkowsky posted on Less Wrong that was the one to beat. Paul Cristiano wrote a post where he didn't, in fact, give any principles for corrigibility, but talked about whether that was a crisp concept or not, and kind of rejected the principle. John Wentworth, 16. Someone called Anonymous AI Safety with 11. Laura Langoska with 14. And yeah, then people going just down. You can see everyone here. Just about the only person that I know from outside Less Wrong posts would be Richard and Go with 6 principles. So counting up these, we get a total of 99 principles. That's quite a lot. And one of the key things that I was looking for was some kind of meta principle that helps us trade off these principles if we if we can't satisfy all of them. And that was unfortunately one thing that no one had any principled idea of how to do. Also, one thing that I was a bit angry when I read all this was that on Less Wrong, people are totally not upvoting as much as they should. Like, if you look through this this list, like the lower third of them have literally 0 upvotes, except the auto upvote they get by themselves. And I think definitely if you write down the principles of corrigibility, even if you are not very skilled, then just trying that, in my mind, deserves way more upvote. So I went and gave everybody on this list a strong upvote, and I think it's I think it must be demoralizing for some of these people to spend the time and write many hundreds of words in these principles and then get precisely 0 feedback and not even an upvote. But that's not really related to this. Okay, so who did in fact win this? I think that Eliezer Yudkowsky's list is substantially better than any individual list from the rest of the people who participate in this competition. The principles include a lot of things that others are talking about, but in a way more detailed and way more powerful way, and it's many of the other principles that Eliezer Yudkowsky did not have are written in a very superficial way. I think Eliezer Yudkowsky's list is certainly the best, but his pessimism, like whether other people could write something like that, I would say that is somehow falsified. In particular, Ivan Hubinger's idea of whether number 2 to 5 could do something better, similar combined, I think that is in fact true. If you didn't have Eliezer Yudkowsky's list, but you have had like the next 4 people's list, then I believe that in total would be of higher quality than Yudkowsky's list. I don't think there is a strong conclusion coming from this. I believe that Eliezer Yudkowsky's list is the best by some margin, but not a unsurmountable margin. And now I will go through Eliezer Yudkowsky's 15 principles of corrigibility. And the way I will structure this is that I will bold some of the text. When I bold the text, it means that there is a subpoint here made by Eliezer Yudkowsky that none of the other 19 people had any mention of. I've copy-pasted some of Eliezer Yudkowsky's principles, and in all of them he refers to not an AGI, but to a thing that you're building. So whenever you see a thing, then you should think that it's the AGI. So the first principle is unpersonhood. The thing shall not have qualia, and it has nothing to do with safety, but just because it's morally wrong. So it's not really related to corrigibility in my mind, and no one but Eliezer Yudkowsky has this as a principle. Is this in fact a good principle? I would say no. I would say that my morals disagree here. Let's say you build a superintelligence and it does have qualia, and it does in fact suffer. Even in that case, if the AGI is only doing a pivotal act and then can be safely shut down or compensated or made nicer in some way, then even very substantial suffering, like in the one who walk away from Omelas, even something like that, I think would be certainly acceptable. And I think, in fact, consequentialist utilitarianism, I don't think Eliezer Yudkowsky is one, but I am, and I think it is just about required. And if I could do something that would be really, really aversive and be really tough on myself, but would literally save the world, including myself, then I think it's morally required to do so. So I went to San Francisco, not just for this reason, and talked with Eliezer Yudkowsky and presented my objection directly to Eliezer Yudkowsky and said, I think it's required to do so. And Eliezer Yudkowsky did not agree. And he argued that the suffering could possibly be really, really severe. And we didn't make much progress. I've kind of felt like when you're talking with someone who have like a different meta-ethics, it sometimes feels like you're talking with an alien. We didn't get anywhere. But I did, in fact, present that objection. I think that this is close to an actual safety principle, however, in that indexical preferences, like if you build an AGI, then if you can separate out the parts that refer to itself for things like qualia, then I think that is probably a good thing to do as much as possible to reduce suffering, sure, but also like reducing suffering from the AGI does have substantial safety implications. And of course, the reason why this is, or my guess of why this is included in the story in particular, is that DATHILAN is a society, a civilization that cares very, very much about morals. And not building an agent that suffers is something they strongly, they really, really don't want to cause suffering. The second principle is taskishness. And if you're building like a limited AGI with a limited task, then that's something that's hopefully limited in space, doesn't take too much time, and it's also probably something that you should limit how much probability you want to be to actually obtain this, in the sense that doing something, a pivotal act with a probability of 99.999 is probably fine. But if you try to have the task bounded, so it must be 99.9999, and with enough nines, you end up with a strange with strange solutions. If you want to have the probability of failure below 1 in a trillion. So Eliezer Yudkowsky is the only one who recognizes that the taskishness must also refer to probabilities. And so, of course, this is something, a principle that was stated in this way in the actual competition. So that is like the task, but there is also the input to the task, whether that should be bounded. And Eliezer Yudkowsky says that should be bounded. The knowledge and effort should be bounded. Again, the limited effort is also something that's unique to Eliezer. And the idea that this principle applies fractally at all levels of cognitive subtasks. So it's not just that the thing that it wants to do is bounded, but everything that all subtasks are also bounded in the same way all the way down. So, as an example, there are no while loops, a programming structure that is that can be open-ended, but only limited enumerated loops, and doesn't try to think of every solution or member of a category, only at most 10, and doesn't try to think as long as it can until it finds a solution, but only in some bounded time. So I think that is something that certainly makes an AI more corrigible, easier to bound, to limit. It limits meso-optimizers, but I don't think it would in fact stop it. Next principle is mild optimization. This is quantizers basically. The AI only seeks adequate solutions and stops looking once it has one. And it's not trying hard to optimize and get the best solution for anything. Except actually Eliezer Yudkowsky uniquely makes an exception for this. There might in fact be some small areas where finding the optimal, the best solution is in fact required. And he puts up some requirements here for when that is allowed. And the reason, of course, is that if you optimize really hard for a solution, you are going to, like, the variables that are not in being optimized over are going to be extreme. To what extent will this work? That's an interesting question. I suspect, in fact, that adequate solutions, if you stop once you have an adequate solution, one of the first solutions you may come up with is taking over the world. And that's certainly adequate. And many pivotal acts are in fact really, really difficult, and taking over the world might be easier than that. I think quantization can in fact be a strong principle for corrigibility, in the sense that we have other methods to try to avoid having the AI think of taking over the world, and when it's not thinking of taking over the world, in that case some kind of quantization is probably something that contributes positively to corrigibility. Here is a principle that Eliezer Yudkowsky has that I haven't seen before, and that no one else seemed to have presented before. I mean, probably there is someone who else who has thought of this, but I've never seen it before. Tightly bounded ranges of utility and log probability. Let's say that you have some kind of action space, and you are thinking of different things that could happen, and then there are also some things that could happen with a very low probability, like 1 in a million. How much should you think about these very, very rare cases? Well, you should probably think about them a little, but mostly they can be disregarded. But it's possible that the AI will at some point come up with some strange part of the action space that looks really, really malformed in some strange way, and assign substantial value to this. And in that case, we want to this is what we want to avoid: throw an exception or just stop or avoid it. in a similar way, the utility it gets from different kinds of solutions should not vary unbounded. So it's not something like create as many paperclips as possible and you get one util for each paperclip. It's more like you can get between 0 and 1 utility, and you could expect that a good solution will get 99.99 or something. So you're using the full range. So you like cut off the really extreme solutions in that way. And the suggestion, once you get something that differs from this, then you should throw an exception. This is a thing in DATHILAN that is much more general than in our societies. They have a principal system of exception handling on an organizational level. So for the context of this story, it makes sense to just say throw an exception. For real life corrigible projects to build a corrigible AI, we will need some kind of principled way of handling this. And a lot of people in their principles talked about how to handle this kind of warnings or exceptions or errors. There are a number of suggestions, some of them actually directly opposed to each other. I won't go into all the details. There are a number of ways you could do this. And ELIEZERS also says that if you can't find a good solution without thinking of improbable events, then that is really worrying. My idea for how to handle this is somewhat different. I think once the AI tries to get a solution and fails in this way, then obviously some of the principles need to be constrained and need to be relaxed. And we need some kind of principled way to do that. Like the simplest is just to drop the fewest number of principles. That's way too simple. I think we can do a lot better. But we need some way of some meta principle to handle this. Then we get to low impact. That is a solution that doesn't change a lot of things that are not almost always changed by non-extreme solutions of the task. So I think this is a cute way of trying to formalize low impact by having just a binary is a particular solution extreme, yes or no, and moving that into a detailed impact measure. I think that's an interesting way of going about that. I think that works in just about every case except pivotal acts, unfortunately. Pivotal acts are likely to be extreme in my view, and unfortunately I don't think this is going to be sufficient to help us. And ELIEZERS warns us that this is a lot easier to say low impact than actually formalizing this. The text says it's easier to illusory name in Taldane. Taldane is just the common language. Think English. And part of the reason why this is complicated is that the thing is learning its own model of the complicated world with an ontology and representation that you don't know when you want to define impact. Of course, trying to reduce impact as much as possible is another recipe for disaster. But ELIEZERS uses an image, I think it's from Fantasia, where you have an animated broom that is filling a cauldron, and most ways of filling a cauldron will not cause the workshop to be flooded, and that means that if the animated broom finds a way that involves the workshop being flooded, then that's probably not low impact. So how can we get around the problem that we have a hard time formalizing this? And I have an idea, a principle that we want a solution specified by humans that is poor on some dimension, and try to improve on that rather than trying to create a really new a new solution. I've written here about how you could do that for different pivotal acts. It's kind of like a half-baked idea for a principle that we could substitute for low impact in case this is too hard to model. Now we get to the principle of myopia, and myopia. The standard way of thinking is just don't think about long-term time horizons, and that's how most people thought about it. ELIEZERS has a more complex definition of myopia. We break the work into subtasks. Work can be both planning and execution, where each subtype task takes limited time, or, in my view, also influences a limited space. And there is some kind of compact description of the final state of this task, so we can determine if the final state is acceptable. And then, instead of just having one instance of the AGI that looks at the entire task, we break it out into different instances that don't look beyond the result of their own subtask. This is nice if it's possible. It might very well not be possible from a lot of practical cases. I think at least a limited principle of myopia is required, in the sense that we want the entire task to satisfy this criteria. And I think if the entire task does not satisfy this criteria, then that would be a very problematic thing. If working at the task could not be done in a myopic way. Separate superior questionnaires. So the question, if you have, in particular, if you have something that is myopic, you might have a separate instance of a separate AI that looks for long-range impacts. This is something that a lot of people have thought about, how to get this kind of AI help in getting questions. AI safety via debate was one of the options. And this separate questionnaire should return just one bit and not be used by the AGI to try to build solutions. So it shouldn't be like it's optimizing against and finding the best solution that the long-range questionnaire can accept. It needs to be stronger. The AGI, the one that checks whether a solution is safe, have more cognitive power. One of the ways would, of course, be to relax some of the principles, like myopia. We would probably want that the questioning AI is less myopic than the AI that builds solutions. And an interesting idea here is that this should be a not just a separate instance, but an entirely different algorithm and architecture. And I think that's interesting. And I think a very hot take is that if we ever find an AI that seems like it could be corrigible, then large language models may indeed be something that could fulfill the role as a separate superior questionnaire, in that it is the large language models are very powerful and of course will have a very different architecture. But it's kind of a hot take. I don't think large language models are likely to be part of a solution. Conservatism. If you're searching for a solution, choose an unsurprising one relative to your probability distribution. It doesn't really sound like conservatism in the way I think about conservatism, like unsurprisingness. Conservatism, to my mind, have two parts. If you look at the full task, or more likely a subtask, then there is conservatism in means and in goals. And both of these are important, but I think the principles and the how different they are, how they should be treated from a safety point of view, is quite different, in that very strange means are more acceptable than very strange goals. And of course, pivotal acts in particular, we would want to maximize some kind of conservatism. In this case, we can't probably get a lot of conservatism, but this is like a surprising pivotal act. Sounds like something that is almost certainly going to be not nice. And part of Eliezer Yudkowsky's insight in this principle is, again, that this is something that applies fractally to cognitive subtasks. And of course, also, again, as before, we're not trying to choose the least surprising one, because, again, every time we are optimizing something that we don't really strictly need to optimize, we introduce a lot of potential for very weird behavior. And weird behavior is, in fact, the key thing, in that we're trying to do something that is weird. Pivotal acts are strange by definition, and if the solution is weird, then we need to kind of manage the weirdness, in the sense that we will get something that is weird, but it can't be too weird. Conceptual legibility is also something a lot of people talked about. Like, we're talking about interpretability here. And Eliezer Yudkowsky's formulation is that solutions at all levels of cognitive subtasks should have short descriptions in the conceptual language of the operators. This is somewhat different from the standard interpretability work, which is written here as obviously dangerous thing. Reportability, which is something that some of the other comments suggested, that the AI tries to explain somehow its plan to humans, even though the plan itself contains some structure that humans can't understand, in some sense, can't natively understand. I think when I think about this kind of interpretability work, I think about the analogy of a human who is like an alchemist, and a chemist AI that is trying to explain something to the human. And in this case, these short descriptions in the conceptual language of the operators may just not exist. Like the alchemist is thinking of things like the four humors or something like that, and the chemist is talking about like atoms and molecules that are just simply not present in the mind of the human. So I think that this kind of conceptual legibility is too high a barrier. I don't think, in fact, an AI that is capable of performing a pivotal act will be able to have conceptual legibility. I think we will need to go for something less ambitious, and to my mind that is something like strategic legibility, in that a lot of the concepts may not be legible and we'll just have to accept that, but the strategically relevant concepts should be legible. Those are the ones we really can't afford to compromise on. Operator looping. Well, how much should you keep a man in the loop? A lot of people say, like, as much as possible, without really recognizing that this is in fact fundamentally impossible. Because, as Eliezer Yudkowsky puts it, if the operators could do the job, then there wouldn't be any need for the AI. We only want it to do a pivotal act that we can't do ourselves. It is, however, still possible that there is a part that the operators can do themselves without slowing the AGI down too much. In that case, it should obviously be done. So doing the thing is quite different from what's called oversight, which is a related principle that a lot of other people have picked up on. Whether it is, to my mind, I would expect that verifying is in fact substantially easier than doing the task themselves. But of course, this depends on whether the subtask is in fact legible to humans, which might very well not be. And of course, even this requires that there is no adversarial sense in the AI. If it tries to push some of the work done to humans, then that requires that the AI is not really adversarial at this point. Again, to my mind, this is something we should exclusively do in strategic matters and not in some technical things like trying to build nanotechnology or things like that. Whitelisting is an interesting concept that I must state up front I did not in fact understand. And the big problem is that there are really no examples. Here is how Eliezer Yudkowsky defines whitelisting. Every part of the system that draws a boundary inside the internal system or external world should operate on a principle of ruling things in rather than ruling things out. On like the object level, if you just literally do that, it seems like that will be really, really expensive and uncompetitive. Like for instance, if you take the classic example of the complexity of values, that's something that you really can't capture, human values, using whitelisting. So I think that is probably not going to work. But this, like, don't take my comments with too strongly, because I don't really understand what Eliezer Yudkowsky is getting at. I think this could be related to perhaps the hard problem of corrigibility, and I think it could in fact be really important. I would like to know what Eliezer Yudkowsky is thinking of, and he claims that there are a number of principles he have not written up, and I think he should totally do that, because I'd be interested in reading his thoughts on this. Shutdownability or abortability. So a lot of people noted that there is this creating an AGI that has a shutdown button, but is not motivated to make this button be pressed, is a substantial problem. Eliezer Yudkowsky points to some research 7 years old summary that says that actually doing this is really hard, and Miri has tried to formalize this and somewhat failed. And he points out that the principle is one that needs to apply almost fractally, in the sense that if the AI builds something, perhaps a sub-agent, perhaps some kind of mechanism, then that also needs to have an off switch that you can press that turns everything off, and not just the sub-agent, and gets a low impact after that. Again, with the analogy of the animated broom. So how hard is this in fact? I remember Stuart Armstrong doing work that was later than this link, and I remember seeing something, like, it's a long time ago unfortunately, so I can't quite remember it, but I do remember him getting somewhere with this. I don't think it's fair to say that it was just totally impossible, and certainly that it's true that it's no challenge at all. So before we get to the next principle, I'll just talk a bit, or I'll let Eliezer Yudkowsky talk a bit about modeling adversaries, because that is something that can indeed be problematic, and something that I think we should have some kind of very strongly principled way around, because I can foresee a lot of different problems coming out from this kind of thing. And I think in particular, one thing we might want to do is to just have the corrigible AI be unable to model or think about other AIs in general, primarily to avoid collusion, which I think is likely to be a very real problem in practice, where there's not just going to be one corrigible AI but many. Eliezer Yudkowsky is more talking about things like the AI considering whether it's in fact inside a box and whether other adversarial minds exist. I won't go into a lot of details about his theories. I think they are totally valid, but I also think they are we need some kind of strong superclass to get around this problem, rather than trying to rule out the first 10 things we can find in the space. This kind of modeling adversaries is avoided by a principle that Eliezer Yudkowsky calls behaviorism. And the thing that he calls behaviorism is basically not modeling other minds at all. That's of course a superset that fixes this problem. I'm not entirely sure I like the word behaviorism for this. I don't think behaviorism means don't model minds. I think the technical meaning is quite different. Things like whether people have like free will and personalities and things like that is again different from the strategic considerations in my mind. I think there are a number of good reasons to not model minds at all, both AI and humans. I think that is in fact a nice thing, and that is this is Eliezer Yudkowsky's argument for why the corrigible AI should not model minds at all. I think it's probably too large. Not modeling minds at all rules out a very large number of pivotal acts, as far as I can see it, and it certainly makes it like uncompetitive. Yeah. Yeah. So the one of them would be forming some kind of positive singleton. Like if you could have a pivotal act that involves a world government that is benign and takes AI risks seriously. That would be an example of a pivotal act where convincing people to take to set up a world government, a benign world government, will almost certainly require modeling the minds of politicians and voters and organizations. Not the minds of organizations, but politicians and voters have minds, and you cannot in any feasible way convince people to set up a government that bans unaligned AGI without modeling their minds. I think many other actions, in fact, also, like a classical example is using nanotechnology to melt all GPUs. Is an example of another pivotal act, and I think in order to do that in the real world, where there are other people working against you strategically, you need to model the other people who are working against you, and you need to like think what would be the reaction of the American president if we suddenly melt all GPUs. I don't think you can get around that in any meaningful way. I hope that answered the question. I think a totally single-minded engineer that is super good at nanotechnology cannot in fact take over the world. You need someone to put that into a strategic frame and to make that into a real plan, and real plans in general require thinking about what would other people react to my plans. Yeah. I think like it does like strong behaviorism defined in this way, like not modeling minds at all, does seem like something that would really make it hard for an AGI to take over the world. It needs to be a very strong power imbalance to have an AGI that's so powerful that it can take over the world without modeling the humans and how they would resist. I think it's not totally impossible, but that is a very strong corrigible element. So, design space anti-optimization separation. Like, can you guess just from the title what that means? Well, it refers to the well-known thing that if you somehow put your utility function into the AI, well, then if you make a sign error, then suddenly it's not maximizing your utility function, but minimizing that, or you could get a cosmic ray or something like that, and you could get blackmailed in some way. Eliezer Yudkowsky have some funny, or not funny ways this could happen. I think this is not that related to design space anti-optimization separation, in fact, in the sense that if you, no matter what the AGI has as a utility function, it would be possible for an adversary to just model that and threaten to minimize that. And in fact, if we are trying to have a taskish AGI that is just trying to do a pivotal act and then shut down afterwards, then it doesn't actually need to have a model of our utility function. Like it's not supposed to maximize and change the universe in according to our values. It's just supposed to do one simple thing and then shut down. But a lot of corrigibility suggestions by the other people who reply to this thread suggests that having some kind of reference to human values to use as some kind of sanity check is valuable. And I can see it could be valuable, and in this case we have two principles that are directly opposed to each other. And again, we have no principled way of weighing these two things against each other. There's a principle of epistemic whitelisting or domaining, thinking about separate domains separately, and not across domains, because across domains is part of the place where a lot of the danger comes from. If you're thinking about like how would the operators think about if I obtain this knowledge instead of this knowledge when you're trying to do something really specific, that seems like something that's almost always going to go wrong. This is close to Eric Drexler's comprehensive AI services idea, where there are wholly separate AIs in each domain, in each silos that are narrow. My expectation, certainly from my objection to Eric Drexler, was that if you want to make it strongly narrow and really have the AIs in each domain unable to do any kind of cross-domain reasoning, then strongly narrow AIs are almost certainly going to be strongly uncompetitive. Or if you want to relax this even just a little, then you're going to get information from one domain onto the other very easily. It's really, really hard to keep knowledge in silos away from an AI that's more intelligent than you. It can figure out the truth in based on really small evidence, which I think is actually a major point in mad investor chaos. My objection to this isn't one that is at odds with what Eliezer Yudkowsky is writing, but I think in fact that a principle of competitiveness is required for how to build a corrigible AGI, in the sense that if you try to build an AGI to solve some kind of task, but the performance is too weak because you are putting too many constraints on it, then at some point it will just be too slow and the comet will hit the earth anyway. So you need to have some kind of performance minimum from the solution, and if you're not reaching that performance minimum, then you need to start doing, relaxing, for instance, the epistemic whitelisting criteria. And of course, for our case, it's a lot worse than for DATHILAN's, because we are probably going to be in some kind of strategic race between a corrigible AGI and a potential unaligned AI. Finally, we get to the last principle. Principle number 15, the hard problem of corrigibility or anapartistic reasoning. Like, I tried to figure out what does anapartistic reasoning mean. And like, I could see that Eliezer Yudkowsky had used this word, and just about no one else had used this word. And I couldn't figure out the etymology. I really don't know what anapartistic means. I would really like to know that, because the hard problem of corrigibility is interesting. It is if I was doing YouTube videos for engagement, I would have like a thumbnail with me saying, pointing one simple trick to solve AI alignment. And this anapartistic reasoning is in fact one simple trick to solve the alignment problem. And this is figuring out how to make the AI want to be corrigible. And if there is some part of corrigibility that we haven't figured out, then you want the AI to figure that out. imagine what hypothetical operators would want if they were building an AGI that thought faster than and whose thought were hard for themselves to comprehend. And figuring out how can you make yourself more corrigible and do that in a way that even though it seems like it is helpful, it is surprising and thus not helpful. One way I've seen this stated is that you want the AI to its inner mental model should reflect the external model that the programmers have. So from the programmer's point of view, the AI is has values that are almost certainly wrong, and we want this to be reflected in the AI in some deep sense. And Eliezer Yudkowsky claims that in DATHILAN, people wouldn't try to build this into a thing. Like, they would almost certainly build it into a full super intelligence if they ever got around to make one of those. But the assumption in this corrigibility principles is that you are under a very severe time pressure in order to build this. And this is a principle that is too deep, meta, and elegant and hard to pin down. So you wouldn't try to actually build this into something if you are, unless you have a lot of time and a really strong understanding. I think Eliezer claims that no one would consider doing this, actually, and I think something like 5 people wrote in their comments some kind of suggestion to that a principle that is related to the hard problem of corrigibility. How hard this in fact is an interesting question. I think Eliezer Yudkowsky is perhaps a bit negative about how difficult this principle is. 5 people suggested we should build it, but none of them had like any real idea about how to go about this. It's possible indeed that Eliezer Yudkowsky's principles are more realistic in the sense that he is saying this is hard, and he has done in fact a substantial amount of work in trying to figure out how to do this, and then a number of people saying we should try to do that without looking into how would you actually go about this. I think in this case I would trust way more Eliezer Yudkowsky because he has tried hard to solve this problem, even though he has failed, and that is why I think the Eliezer Yudkowsky's 15 principles for corrigible AGI is the best one in this competition. That is all for today. Thank you and see you next time.